Hello students. In today's class, we will look into one more example of knapsack problem. Let us go through the problem statement. Consider a knapsack size to be 100. Three objects have to be used. Okay, now that means what? The total size of the given knapsack bag is 100 here. So that means M is going to be 100. Three objects have to be used, right? So three objects means the number of objects over here are going to be three. Let's consider n as 3 here. N is equals to 3. Total weight of the objects. The total weight of the objects is half times more than that of the knapsack capacity. Now, if you look into this particular statement, the total weight of these three objects is not given directly, but it is given indirectly, wherein we need to calculate that particular total size by using the size of the knapsack. Okay, then the individual weights of the objects are 25%, 40%, and 35% of the total weight. Okay, now that means first we need to identify the total weight based upon the knapsack size, and then by making use of these percentages, right, these percentiles, we are going to calculate the individual weights, right? Then also they have given the profits of individual objects, right? The first object's profit is 50, second is 65, and third is 60. Now let us first calculate the total weight. Okay, now total weight is going to be what? It is going to be the half time more than that of the knapsack capacity. So half time more means what? Here knapsack capacity is what? 100. Let me try to write in this way. Knapsack capacity is 100, right? Half time more than this particular 100 is, that is 50. So total weight is going to be 100 plus 50. That is 150 is the total size of the three objects. Okay, the total height now we calculate it to be 150. Now using these three percentiles, now we are going to calculate the individual sizes. Okay, now students, how we got this 150? As per the program statement, it says that total weight of the object is half times more than the knapsack capacity. Knapsack capacity is 100. Half of the knapsack capacity is what? 50. And they have said that it is half time more. So 100 plus 50, that is going to be 150 as the total weight. Okay, so the total weight we have calculated here as 150. Now let us calculate the first object's weight. Let me denote it as W1. So W1 is what? It is 25%. It is 25% of what? It is 25% of total weight. It is 25% of total weight. So we need to compute here. So if you solve this 25%, it is going to be what? 25 multiplied by total weight, that is 150, then whole divided by, let me put the brackets here. So 25 multiplied by 150 whole divided by 100. So if you solve this one, we are going to get the weight of W1 as 37.5. Same way, let us calculate the second object's weight, that is W2 is equals to, W2 is 40%, right? That is 40% of total weight, right? Again, it is going to be 40 multiplied by 150, then divided by 100. So if we solve this equation, we are going to get the weight of W2 as 60. Then the third one, W3. Sorry, W3 is equals to it is 35%. So 35% of total weight. Again, this is going to be 35 multiplied by 150 divided by 100. So here we are going to get the value as 52.5. Okay, now we have computed the values of W1, W2, and W3 by calculating first the total weight. Okay, so now we are given with, now we have the all the values, that is we do know the knapsack size 100, then we have the objects, the weights of individual objects, and also we are already given with the profits, right? We are also given with the profits of the three objects as 50, 65, and 60. Let us calculate. First task is that we need to calculate the profit per weight ratio, that is pi divided by wi, we need to calculate. So pi divided by wi is going to be first p1 divided by w1, then p2 divided by w2, then p3 divided by w3. Okay, now p1 is, in this case, the P1, that is the profit of first object here, is 50. So 50 divided by W1. W1 is 37.5, right? Then P2. Let me put it on the other side. Okay. P2 is 65. 65 divided by W2, that is 60. Then third one is P3. The profit of third object here is 60 in this case. So that is 60 divided by the weight, that is 52.5. Okay, now if we calculate these values, so we are going to get the first profit per weight of the first object as 1.33. Then the second one is 1.08. Then the third is 1.14, right? So by looking at this profit per weight ratio, we can clearly say that the object, that is the W1 or the P1 profit, if I choose this particular object, I'm going to get the more profit or the highest profit. Then I need to choose the third object and then the second object. Okay, so now let us try to rearrange all the objects, rearrange the profit and weights, rearrange the profits and weight in decreasing order. So P1, P2, P3, okay, then W1, W2, and W3. So P1 is going to be straight away, we're going to pick the first object itself, that the profit is 50 itself. Then P2 will be the P3 actually, so that will be 60. And then P3 is going to be the P2 value, that is 65. The same way, the corresponding weights we are going to write down. 37.5. Then the second weight, that is 52.5, and then is the 60. So these are the rearranged profits and its respective weights. Now, first we need to initialize our solution vector. So initializing solution vector. So we get x1 is equals to 0, then x2 is equals to 0, and x3 is also equals to 0. Okay, now the solution vector we are going to choose in this way. X1, now the total capacity is M, that is M is here 100. So assume that there is a bag with you and which can take 100 kgs in that, 100 kgs of objects in that. So the first object, the profitable object is with respect to the first object, that is weight is 37.5. So in 100 capacity bag, I can easily fill all these 37.5 kgs. So the X1, I'm going to consider it to be a whole value. So all these particular 37.5 kgs, I'm going to put it into my knapsack, right? So once I put this in the whatever remaining capacity I have, in that I will be definitely able to put all these 52.5 also. So the X2 will also be equal to 1. Now, if you add up these two, that is 37.5 and 52.5, how much it will come? Say 37, this is 0, this is 10, 3 plus 5 is total 90 we get, right? So we have a capacity of 100, but already it is filled with 90 kgs, assuming that way, 90 kgs. Then what is left out? Only 10 kgs. But the the cost of or the weight of the third object is going to be all 60. But we cannot fill all these 60 into our knapsack. But what we can fill with its a partial values. So now X3 is going to be remaining is only 10 kgs and I have 60 kgs. So it is going to be a fraction of 10 divided by 6. Okay, so let us keep this as 10 divided by 6 as it is. Later we will calculate the values, or else you can also write down the fraction of that. That is also okay. I'm just keeping it as 10 divided by 6 itself. Okay, next. Let us calculate now maximum profit. Maximum profit is equals to, that is nothing but the summation of Pi into Xi. So Pi in summation of Pi into Xi is what? Nothing but it is P1 into X1 plus P2 into X2 plus P3 into X3. Let us substitute the values here. So if I fill the values, the P1, the profit is 50. So 50 multiplied by X1, X1 value is 1 plus P2, P2 in this case, let me rewrite these values, students, here, that is 65, right? Okay, so P2 is 60 plus X, that is sorry, into 1 plus P3, that is 65 into the X3 value. X3 value in this case is 10 divided by 60. So this is going to be 50 plus this is going to be 60 plus, if you solve this 65 into 10 divided by 60, we will get somewhere around 10.83. If we add it all these three values, we get the value as 120.83. Okay. This is the maximum profit that we will earn if we choose the objects in this way. The next, we are going to validate by calculating the summation of summation of Wi into Xi. So this summation of Wi into Xi should come exactly equal to the total capacity of the knapsack. W1 value is 37.5 multiplied by xi. Okay, first let me elaborate the w1 and x1 values. So w1 multiplied by x1 plus w2 multiplied by x2 plus w3 multiplied by x3. Then w1 value is 1, sorry, w1 value is 37.5 multiplied by 1 plus w2, that is 52.5 multiplied by 1 plus w3. W3 here is 60 multiplied by x3. x3 is nothing but 10 divided by 60. Now students, here you can see why in the previous step here, why I left it to be 10 divided by 6 itself. It will be easy to calculate at this particular stage. So we get this as 37.5 plus 52.5 plus 10. So this is going to be 100, right? So the summation of Wi into xi is exactly the total size of our knapsack. Okay. So this particular question, if you look into the program, the question statement, they have not told you they have not given you the data directly. The size or the weights of individual objects are given in a percentiles, right? So first we have calculated the total size or the total weights of all the three objects, and then individual size we calculated, and using those values we rearranged the power per weight ratios, and then we calculated the maximum profit and the summation of Wi xi as well. Two more problems I will give you students here. These problems you can solve at home as a home assignment. Find the optimal solution and the profit for the following knapsack problem. In this, the total number of objects are 7 and the size of the knapsack is 15. So P1, P2 up to P7. So P1, P2, P3, P4, P5, P6 and P7 are the profits of the 7 objects in this order. So P1's profit is 10, P2's profit is 5, like that P7's profit is 3. The respective weights of the objects are going to be 2, 3, 5, 7, 1, 4, 1. Right? So first calculate in these two examples. In these both the examples, the inputs are given directly, all the values are given directly. First, you need to calculate the profit per weight ratios. Rearrange them in a descending order so that the highest profitable objects are chosen first. Okay, and then initialize the solution vector. So in this, you are going to get in both examples, you are going to get the solution vectors as x1, x2, x3 up to x7. Initial values are going to be zeros for all these 7. Then start filling up the x1, x2, right? And then calculate the maximum profit using the formula summation of pi into xi, and then verify that particular profit by calculating summation of wi into xi.